There are shortcuts hidden in the fabric of the universe. Passages so strange that if you stepped into one end, you could emerge light years away instantly. These are wormholes, the universe's most mysterious tunnels, predicted not by science fiction, but by Einstein himself. Welcome to Cosmicnova. Today, we explore the hidden tunnels of spacetime, wormholes. In 1935, Albert Einstein and physicist Nathan Rosen studied the math of spacetime and discovered something shocking. Their equations allowed a bridge, a tunnel, connecting two distant points in space. This became known as an Einstein-Rosen bridge, or what we now call a wormhole. To understand a wormhole, imagine space as a flat sheet of paper. If you fold the paper and bring two distant points together, then poke a hole through, that shortcut is a wormhole. It doesn't move you faster than light, it simply removes the distance. A wormhole is not just a tunnel through space, it's a tunnel through spacetime itself. It connects one location to another instantly, regardless of distance. If wormholes exist, they could link stars, galaxies, or even entirely different universes. If you stood near the entrance of a wormhole, you would see a glowing circular sphere, like a cosmic mirror. Through it, you might glimpse an entirely different part of the universe, distorted and swirling as if space were liquid. The moment you step inside, space begins to stretch and twist. Time flows differently. Gravity shifts direction. The tunnel feels endless yet fleeting, a corridor of pure geometry where normal physics breaks down. There's one issue: wormholes are incredibly unstable. According to current physics, a natural wormhole would collapse instantly, faster than you could enter it. Its walls would pinch shut, destroying anything inside. To hold a wormhole open, scientists believe we'd need exotic matter, material with negative energy density. Not antimatter, not dark matter, something stranger, something we've never seen. If it exists, wormholes could remain stable long enough for travel. But even if we could stabilize a wormhole, where would it take us? Another star? Another galaxy? Or a universe with completely different laws of physics? To find out, we must step deeper into the tunnel. As you step through the shimmering entrance of the wormhole, the universe behind you stretches into a distorted halo of light. What was once a familiar star-filled sky now bends into a whirlpool of colors and warped geometry. You've crossed the boundary where normal physics begins to unravel, a place where space and time twist into impossible shapes. Inside the wormhole, the tunnel walls aren't solid. They're made of flowing spacetime, a living, shifting surface that ripples like liquid light. The tube stretches, shrinks, and twists as gravity fluctuates wildly. You're not moving through the tunnel. The tunnel is moving around you. In a wormhole, motion is an illusion. You aren't traveling at high speed. Instead, the fabric of spacetime itself is sliding you from one point to another. The journey could feel like seconds, even if the destinations are thousands of light years apart. Once inside, time stretches and contracts unpredictably. Moments may flicker like broken film or drag out endlessly. A second for you could be years outside the wormhole, or the opposite. Time becomes flexible, bending in ways our minds can barely comprehend. Surprisingly, the tunnel's interior is calm. Outside the wormhole, tidal forces around black holes could tear anything apart. But inside a stable wormhole, if exotic matter holds the passage open, gravity becomes balanced. It creates a smooth path through the cosmic corridor. As you drift forward, the tunnel ahead shimmers with distant light, the exit. But it doesn't look like a normal starfield. It's distorted, bent, magnified, stretched. Could be another part of our galaxy, or something far stranger. A wormhole doesn't have to connect two places in our universe. Some theories suggest the tunnel could open into a parallel universe, a different time period, a region with alternate physical laws, or a completely isolated pocket universe. A wormhole is not just a shortcut, it might be a doorway. General relativity predicts that wormholes could connect any 2 points in spacetime. This includes points separated not just by distance, but by time. A stable wormhole might allow you to exit in the future or the past. But wormholes are fragile. Even the smallest disturbance, a wave of energy, a shift in mass, a tiny vibration could trigger collapse. If the tunnel closes while you're inside, you would be crushed by unimaginable tidal forces as spacetime snaps shut. But for now, the tunnel holds. The swirling exit grows brighter. The fabric of the universe beyond the tunnel calls to you, pulling you closer. Where does it lead? Is it our universe? Another universe? Or a place no human mind has imagined? To find out, we need to step through. As you drift toward the shimmering exit, the wormhole begins to vibrate with a deep cosmic hum. Light at the tunnel's end expands, glowing brighter than any star. Your vision warps as the walls behind you stretch into the infinite distance. You are moments away from discovering where the universe has taken you, and whether this journey ends in familiarity or something unimaginably new. And then, it happens. The tunnel collapses behind you with a silent flash, and you emerge into open space. The transition is instant, like stepping from one room into another. Yet the distance between those 2 rooms could be a billion light years. Around you, the stars snap into focus, reshaped by the physics of your new surroundings. Perhaps you find yourself in a completely new part of our galaxy, near a distant nebula, a star cluster, or a lonely black dwarf star. The environment may look familiar, yet alien at the same time. The wormhole hasn't just moved you. It has delivered you into an untouched corner of the universe. But what if this place doesn't belong to our universe at all? Some theories suggest wormholes connect not just distant locations, but entirely different universes. Here, the laws of physics might behave differently. Light might bend in new ways. Gravity could feel weaker or stronger. Stars may burn in unusual colors. Time may pass at a different speed. You might have stepped into a parallel reality. One of the most powerful ideas is that wormholes could end at a white hole. A white hole is the reverse of a black hole. Instead of pulling matter in, it blasts it outward. If you emerged from one, the view would be violent and beautiful. An explosion of light and matter streaming into empty space. Some scientists believe advanced civilizations, millions of years ahead of us, might have already mastered wormhole engineering. If so, wormholes might not be natural at all. They could be built, stabilized with exotic matter, and used as cosmic transportation networks across galaxies. We have never seen a wormhole, but we have seen strange gravitational lensing patterns in space. Some of these distortions look nothing like galaxies or black holes. Could they be wormhole entrances disguised by warped light? Perhaps the universe has been whispering clues all along. But even if wormholes exist, using them is unbelievably difficult. The energy needed to create one is enormous, greater than what stars produce in their entire lifetimes. Even stabilizing a tiny wormhole would require technology far beyond anything humanity can currently imagine. In the end, wormholes remain one of the universe's most thrilling mysteries. They could be shortcuts across the cosmos, bridges to other universes, time machines, remnants of ancient civilizations, or simply mathematical illusions. But until we can interact with one, wormholes exist in the twilight between science and imagination, a doorway waiting to be discovered. Whether wormholes become the highways of future civilizations or remain unreachable cosmic secrets, one thing is certain. They remind us how little we truly understand about the universe, and that the greatest journeys may not be across space, but through the fabric of reality itself. Thanks for exploring the unknown with Cosmic Nova. Until next time, keep wondering.